What's up guys, my name is Brad. Welcome back to another video. If you're new to this channel, we talk about welding and fabrication, CNC machining, some Fusion 360 stuff, and we're gonna jump into some really cool projects, so if that sounds fun, hit that subscribe button. On today's video, I'm gonna walk you through the process of how I weld stainless steel tubes step by step for automotive fab applications. We will go over each step, but anything that I've already done an in-depth video on, I'll go ahead and link in a card above so you can go and check that out. All right guys, let's get into it. Better glove up, better safe than sorry, and acetone is some seriously aggressive stuff. I'm not a fan of these gloves at all, but it's what we have, so here we go. This material is from Tommy at FDRFab.com. I absolutely love welding with his material. It is always consistent, and puddle stability is absolutely on point. No toaster ovens and die-cast cars floating around in this stuff. Everything tube related that I do will almost always be 304 stainless steel. Everything from 1¼ to 4 inches typically in diameter. This is some sanitary grade tube and is super clean out of the bag. We will be welding 3-inch straight today, but I'm going to show prep and fit up with these bends. For a more in-depth how-to, you can watch my video on how to prep stainless steel tube by clicking the link above. Always grind your material's faces flat. Deburr, Scotch-Brite, and acetone wipe all material inside and out. Fit up is key. No gaps, no leaks, no oils or contaminants. And please prep your material. It's the only way to make a quality product. So many problems that people have when welding anything is they seem to just want to practice welding and prep falls short. What they realize later is how much they were fighting bad prep, and how it's so much easier to get a good weld with finely prepped material. Let this be the one thing you take away from this video. This is the most important thing when it comes to welding. A simple propane torch is a super easy way to remove anything left behind by the rag you use to acetone wipe with. We will be welding some 3-inch or 76.2mm 304 stainless steel tube with an 0625 or a 1.6mm wall thickness. My cup of choice for this job is a number 17 cup from Michael Furick with an inside diameter of 1.0625 or 26.988mm. We will be flowing about 40 CFH of argon with 0.750 or 19mm of stick out. The 3-inch diameter tube is large enough in diameter to allow us to use a number 17 cup to travel quite far before our weld oxidizes behind the cup. The smaller in diameter the tube, the smaller the cup can be due to the fact you're welding around a smaller radius, and that will typically result in more stops and starts. Not as much coverage needed with shorter runs. Every cup size has its purpose, but a lot of it has to do with personal preference. If you're taking the time to prep your material to a high standard, then why would you want to dip unprepped dirty filler rod into a clean puddle? Acetone wipe your filler. It's never clean from the manufacturer and it will contaminate your weld. On this specific part, we're going to be back purging about 7 to 10 CFH, just depending, making sure we have a nice tight fit up with 0 leaks. We'll be using these awesome silicone purge plugs from Brad Harmer at TIG Aesthetics to do the job. Today we're going to be welding a few joints out of some 3-inch 304 stainless steel. Nice tight fit up, no gaps, no leaks, frequent tacks to make sure everything's sealed well. If you'd like to watch an in-depth video on how to back purge stainless steel tube, click the card above. I believe these silicone purge plugs are good to about 600 degrees Fahrenheit. You can weld with them about 1 inch away from your weld joint, so it makes it super nice on things like this. As with anything, making sure whatever you use to sharpen your tungsten, whether that be a belt sander, a tungsten grinder, or even a flap disc on an angle grinder, it needs to be dedicated to sharpening tungsten. It's a good idea to use 2 belts, one for steel and stainless, and one for aluminum. You can easily embed material onto your belt into your tungsten, and it can lead to wandering arcs, poor arc starts, as well as contaminating your base material. The grind angle on a tungsten also completely changes the arc cone characteristics. A sharp tungsten ground at 25 degrees will have a wider arc cone and give less penetration due to it not being as focused as, say, a bluntly ground tungsten with a 45 degree grind. I'll set my machine just a few percent over what I'll actually be welding. It makes being consistent easier for me than going wide open throttle. And trust me, I did the wide open throttle thing for a good while, but on thin wall tube, so much easier just to set your amperage maybe 10 amps above where you're actually going to be welding at. Here we are at 65 amps on the machine using some 332 or 2.4mm 2% thoriated tungsten. We're going to be using some 045 or just over 1mm in diameter 308L filler rod. If the joint configuration is thin wall to thin wall on a butt joint like we have here, I'll use some 045 or just over 1mm diameter filler. If it's thin wall tube to say 1/4 or 3/8 flange, I'll use 1/16 or 1.6mm filler rod. When I restart after a stop, the easiest way for me to get a nice restart is if I start on the last ripple that I left off on, increase my amperage until the toes of the weld puddle are the same size as the previous welds, wait just a minute to allow for the weld to penetrate and wet out, and then move one dab forward, push the puddle forward and add filler and continue on your way around the tube. How wide the weld profile is depends on how the person wants the weld to look. Everyone has a style. You can have a good quality full penetration weld an 1/8 inch or 2.4 millimeters wide, or even 3/16 or 4.7 millimeters wide. It really depends on heat input and travel speed, but shoot for what looks good to you. Stainless steel like this is an art form in certain industries and laughed at in others, unfortunately. Hold a tight arc and imagine a tangent plane on the tube as you're welding along. You want a push angle on your tungsten, but you want to try to keep your tungsten perpendicular to the tangent plane as you weld around the tube's radius. You can have a tungsten push angle of about 10 to 15 degrees. This is not only important for maintaining good gas coverage, but it will also assist in focusing penetration and preventing your ripple spacing from being elongated. When welding anything, it's like driving a 5-speed transmission. It's a balancing act with your throttle and your clutch. If you are moving too fast with not enough heat, your weld will look clumpy and cold. If you are moving too slow with adequate or too much heat, you're going to overheat your part and your weld will appear dull and overheated. The technique I use for welding stainless tube is super simple. Straight DC current, machine is set to 65 amps. I'm using a number 17 glass and brass hybrid from Michael Furick with 3/4 or 19 millimeters of stick out, no machine pulse, no foot pedal pulse, just straight DC current dabbing along at my own pace. We are flowing 40 CFH of argon and typically back purging at 10 to 15 CFH depending on part size. My ripple spacing is nice and tight due to the filler being a heat sink, and each time you dip your filler you cool the puddle. Longer strides equal more heat. You can move nice and slow or speed it up and you can achieve the same aesthetic result. Just be patient and allow the puddle to stabilize between dabs. If you are just welding one joint, the only crucial thing about tack weld placement for me is just making sure that I have enough tacks on my part and all of my gaps are closed. I usually tack every inch or so depending on diameter and how far I'll be running. If you are welding pie cuts, you can align all of your tack welds so that all of your starts and stops line up real nice and your oxidation profiles look even and symmetrical. The easiest way to be consistent when welding is comfort and repeatability. Make sure you have a place to rest your hand and take a few dry runs so you know you're comfortable and ready to weld. Alright, so let's recap. Material prep and fit up are absolutely most important. Take the time to make nice parts, even for practice. Tack weld placement can 100% reflect how your end result looks. If you weld from tack to tack and you have multiple joints close together, line them up. Cup size varies on your stainless tube's diameter. Make sure you are back purging all of your parts. For a seamless clean tie-in, start on your last ripple and increase amperage until your toe width of the weld matches the previous weld's toe width, and then move forward one ripple and then start adding filler rod. Use 1 millimeter or 0.35 or 0.45 filler on 0.625 or 1.6 millimeter wall tube. Bigger filler requires more amperage to melt, which equates to more heat input. Set your machine to 10 amps over what you would normally weld with. Travel speed varies per person, but make sure you are in control of the puddle. Sharp 25-degree ground tungsten electrodes are my go-to on stainless steel tube. Argon flow is really going to be determined by your cup size. You could be welding with the number 12 cup and use 25 CFH of argon, maybe a 17 you'll use 35 to 40, then you'll get up to a number 20 cup and you'll be using over 50 CFH of argon. Practice as much as you can, and if you have any questions, please feel free to send me a DM on Instagram at Hourglass Ingenuity. As always, there's so many things to learn in this industry. There's so many different skill sets, so many things that I'm forgetting. But over time, I'm going to keep producing content that hopefully answers all of those questions for you guys. As always, thank you so much for watching. I appreciate it. I hope you guys have a good day. We'll catch you next time.